Welcome back to our course Introduction to C Programming. Today we are going to start Module 5 of Week 1. Before we start the topic, let us first see what are the different things that we have learned as of now. Now we know how to design an algorithm from a problem definition. We have seen few examples like Babylonian search method, Euclidean GCD algorithm, and we also analyzed those algorithms, how that can be written in more efficient way, etc. And we also have found some key aspects or key properties of an algorithm which every algorithm must satisfy. Now in today's module, we will formally introduce you with a programming language. How the instruction or steps written in an algorithm can be executed using a programming language in a machine, that is the objective of today's topic. So let's start. We have already seen the Babylonian search algorithm in our previous lecture, and we also have said that these algorithm is basically the instructions which is human readable, that is written in simple and basic English. Anybody who has the logical sense, he can understand this, but machine cannot understand this simple English language. Okay, so our final objective is to run the algorithm using a digital machine or computer. So computer can only understand the machine instruction which is written primarily on binary language, which is the strings of 1 and 0. So there must be somebody or something which can convert this human readable instruction into machine readable instructions. So what we need basically is some set of rules and some predefined programs for this conversion. We will discuss all these rules and programs slowly. So in summary, all this set of rules and programs together, we can say the programming language. Okay, so now let's deep dive into this circle and see what are the different programs and set of rules that we are talking. We will first start with the algorithm, so which we have already designed for Babylonian search method. Now from this algorithm we will create a high level code. Now what is high level code? It is actually written in English as well, but it will maintain certain standards. We need to follow some rules which is provided by the programming language. Now we are talking about C programming language here, so we need to convert this algorithm in C language. So let us take the same example and see how the high level code should look like for this problem. High level program will have something like this. There will be one main function, and then inside that, first line, read the number n and m. So for reading a number from the user, C will use a particular function which is known as scanf function, and this is the kind of a syntax we will use. Okay, we will explain all of these syntaxes one by one in later modules, but first let us understand what the high level code. So the first line, read the number nm, what this scanf is doing, it takes two number and it will actually store the number in n and m variable. Okay, so to work with that, before you load the values into the variable in memory, you need to declare integer n comma n. We need to tell our machine that n and m can capable of storing an integer value. Now then this statement 2, this one, in C language, high level code will be r equals to m percentage n. Now this percentage is used as a mod operator, that is the remainder. If we need to find the remainder between m and n, we use the percentage operator. So this is what the rule, that whenever you need to find a remainder, you use the percentage operator, right? and then if you see, repeat step 5 to 7 until this condition satisfies. So therefore, how we can write it? While, we will write it like that, r greater than 0, you just continue these 3 steps. Number 1, m equals to n, so we will write m equal to n, and then n equals to r, and then again r equals to m percentage n. So these 3 lines we have written down. Now, and it needs to be repeated as long as this condition satisfies. So what will happen if r is greater than 0? First, the value of m will become n, and n will become r, and r will be calculated. Again, it will go and check whether r is greater than 0. If it is still greater than 0, again execute the same thing. So here this repetition is actually mapped by while in C program. And finally, at last we need to print the value. So here again I will write printf, and we need to print the value of the number n. Okay, and we will close the bracket. So here we have started the bracket, and finally we close this bracket here. And if you look into this code, this is what high level code. Now it is not exactly a English language code. Of course it is written in English, but there are some syntax that you need to follow here. So you need to know different operators. You need to know what are the C statement that is used for repetition, and all those things, small mapping rules you need to know. But again, it's not very difficult to understand, as this entire thing is known as, let's say we give the name Babylonian search underscore C. Now since this file, this is the name of this file, if I consider this as a file, this entire is a file, or rather this entire program is known as Babylonian search, of name of the program, and it should have a .c extension. It actually tells that this is a C source file. That means it is written in C language. Now if you notice here, even our digital machine cannot understand this high level code because it is not written in binary. So now let's proceed in the next phase. So in the next phase, there is one predefined program preprocessor that will work on this high level code, and it will create a pre-processed code. Now what is the difference between high level code and pre-processed code? Let's write here, this is what my high level code. Okay, now pre-processed code is similar to your high level code. Only thing is that in our high level code we use lot of shortcuts, like this is the function which is used for storing the data in variables. Okay, now inside this function there is so many C statements, but we are using this scanf as a shortcut. Okay, as a programmer we do not want to run all the statement which is inside the scanf again. Instead of that, we just call this function, then automatically all those statement which is inside the scanf that will run. So therefore all those shortcuts, so this is what the shortcut, and these shortcuts will be filled up by the actual codes by this preprocessor, and it will create another file which will have little more lines of code. Because if scanf, let's say scanf is a shortcut, then it must have some few lines of code. So what the preprocessor will do, whenever it gets any shortcut in this high level code, it will replace with the actual code. Now the shortcuts will be very simple statement, so your actual code may be little longer, so therefore this scanf will be replaced by the maybe few more lines. Similarly, printf is again a shortcut, so we will replace it by some set of statements. So therefore The pre-processed code is basically your high-level code plus few lines which C programming language will add on top of our high-level code. So again, this is also a .c file, but it is modified version of our high-level code. Okay. Next, another pre-built program compiler comes into the picture, and it takes the pre-processed code and it converts the pre-processed code into assembly code. And while converting this pre-processed code, compiler does some kind of an optimization. Optimization means if there is a scope to reduce the unused variables, unused space, memory space, etc., etc., it will optimize that. So those automatic optimization will be done by the compiler while converting it into assembly code. And what is assembly code? Again, it takes pre-processed code and replace all the high level instruction into shorter mnemonics. So shorter, it is again shorter version, shorter mnemonics. Like I can give you the example. Let's say scanf, you use the scanf function to scan a value from user and load it into memory, right? So this is the function which is used in high level, but when it will be converted into assembly code, then the mnemonic will be even shorter, like LDA, that is load the variable, or STA, store it, something like that. So this kind of shorter mnemonics will be used in the assembly code, and as a result, understanding the assembly code is quite difficult for a high level programmer. Okay, and again the another important point is this assembly code depends on the particular type of machine what we are using for the program. Now what I mean to say, that is the high level code and pre-processed code, it never depends on the type of the machine. Let's say I am running my program in a Intel Pentium machine, and then if I move to some other machine like let's say IBM or anything, then what will happen, high level code, pre-processed code, you do not need to change, but the machine where you generated the, let's say you have generated the assembly code in Intel machine, then you cannot use that assembly code directly into some other type of machine, because these shorter mnemonics are specific to the architecture of the processor and machine. So these two steps are basically machine independent. I am writing machine independent, but this step is machine dependent. So please remember this point as well. But again, it compiler does lot of optimization for us, so the code is lighter and more optimum. Okay. Now let's go to the next phase. What is the next phase here? Now another predefined program, assembler, comes into picture, and it takes the assembly code and convert it into object code. Now what is object code? This is what the code which is written using binary language, okay, which machine understand. Okay, so binary language means maybe the first line, this algorithm's first line may be converted by 1000 100, something like that, right? This is a binary instruction. Now if I write in high level C equals to A plus B, then corresponding binary instruction may be 11100 1110. I'm just giving an example. So this means addition, this means the address of the first argument, this means the address of the second argument, or A and B. So in this way the object code will be created, and object code actually is written in binary language. So there are few different types of files we are as of now getting, like .c file, which is high level code, .obj file. Now in this case we use .obj, which is known as object code. Now what happens, this object code is taken care of by another program called linker. And what linker does, in a program we may have different small subprograms. Okay, Now these subprograms are connected to each other. Now what the linker does, it takes the object code, and if it gets several unresolved reference, that is multiple programs, okay, it will collect all of them together and actually create a executable code. And this executable code is basically has .exe. So this is .exe, and this is .obj, and this is what .c, right? These are the main extensions we are using here. Now executable code, you can execute it, and before the final execution, another predefined program loader comes into the picture, and what it does, it takes the executable code and load into the random access memory or RAM, and from that RAM we execute our final program. So this is what full life cycle how the C programming works. Now we do not need to get into much detail of this entire process, but what we need to understand in this course is mainly how to convert a algorithm into your high level language. So this is the thing we will learn in our course. But apart from this, all the other things, that is preprocessor, compiler, assembler, linker, loader, these are all responsibility of the C programming language itself. When we installed C software in our machine, actually we installed all these things: preprocessor, compiler, assembler, linker. These are called system software. So if you can create a high level code, and if you ask system programs to execute that high level code, automatically it will take your high level code and execute one after another all these process, and finally it will run the program for you. So this bigger chunk of system softwares downwards, this one, so all this, that we will not discuss in this course. So we will only focus here. This is what our focus area. So the entire coursework we will learn how to convert an algorithm into a high level language. Once you do that, after that automatically C will take care everything. It will execute all other pre-built programs like preprocessor, compiler, assembler, linker automatically one after another. Now, for this purpose, normally we use a software called IDE, Integrated Development Environment. Integrated Development Environment. Now, what does it mean? This is the last thing, very important thing here: environment. So, if we use an integrated development environment, then you just give this high level code, C will automatically execute one after another all the remaining programs. That means preprocessor, compiler, assembler, linker, and loader. You don't need to bother. But if you don't have any IDE, then first you need to run, you need to take this high level code and you need to run this preprocessor program, get a preprocess code, and then again you run a compiler. On top of that, it will give you the assembly code. So all these intermediate phase that you need to run manually one after another. But if you use an integrated development environment, you do not need to do it manually. You need to click once, build and run. Automatically all these intermediate phases will be executed by the environment itself. So therefore we use integrated development environment for our purpose. So our task is very simple, just to learn the how to convert any particular algorithm into a high level code. Now let us see what are the features of C programming language. First, C is a very flexible language. Initially, C language was developed for system programming, but now it can be used for any application like embedded systems or any business software, anything. Okay, so now the next point is C is very powerful language, and it has a very large collection of data types and operators. Okay, Now these data type and operators will help us to write very complex program within a very few lines of code. Now the third point is standard library. Now C's strength lays on the standard library, which contains hundreds of functions, and these functions will be used for input output, string processing, okay, and maybe memory allocation, string processing, memory allocation, all different purposes. Okay. Now the next point is difficult to modify. Now this is a negative point for C language. Large program written in C is very difficult to modify if they have not been designed with proper maintenance plan. Now if you look into the other language like C++, Java or Python, all these languages have some special features like class, then packages. So all these features help this language to split the large program into multiple manageable pieces. So in that way these languages are better in this point with comparing to C language. Okay. Next point is C is error prone. Now the C's flexibility sometimes make it little error prone. In a lot of cases there are some programming mistakes that will remain undetected in C, whereas most of the other modern languages they can easily detect those defects. Okay. Now the next point is C is highly portable. That means if you run a program in one machine, you can run it to another machine with no or very little modification. Okay. Then finally another point is C's language is very efficient. Actually the C language has developed, okay, for mainly for the program written in assembly code or lower level code. So most of the low level programs needs very faster execution and less memory. So therefore from the beginning itself the inventor of C language special care they have taken so that the execution of C program is very fast and take a very less amount of memory for execution. So if you look into all these properties, there are few properties like flexibility, powerful, these are all advantages. Standard library, difficult to modify is a negative advantage, disadvantage, sorry. This error prone is also disadvantage, portability is advantage, and efficiency is also advantage. And in fact we are seeing here every feature of C is not good. There are few things which is bad here as well. And in fact if you choose any other programming language, definitely will get some features which is good and some of them, very few of them are bad. Now based on your requirement we need to choose the language, but it is for sure you cannot find a single language where you have all the benefits without any drawbacks. It justifies the statement that if someone claims to have the perfect programming language, he is either a fool or a salesman or both. It was quoted by famous computer scientist Bjorn Stroustrup, who is the actually inventor of C++ language. So, dear learner, we have almost finished our discussion for this module. Now, before we leave, let us summarize our discussion for this module. So we have discussed different phases of converting a high-level code into the machine-readable program. We have seen different pre-built programs like compiler, assembler, linker, loader, all they are working together and actually creating the final executable code. In the next point, we have seen different features, various features of C programming language Most of them are good, and few of them can be treated as a drawback as well. And we have seen there are no programming language which is having everything best for that matter. Now the question is, what will come next? So in our next module, we will run our first C program. I hope you have enjoyed this module. So we will meet again in our next module, that is module 6. Till then, stay happy and stay healthy. Thank you.